Today we're going to look at forces, mass and weight. First thing, force. Now, what is a force? Now, forces are described as a push. So when you push something, you use a force which pushes it away from you. A pull. And the one on the right here shows that you're pulling something towards you. And a twist. A twist is when on one side you're pushing away and on the other side you're pulling towards you, so you make it turn round. That's a twist. So these are the three kinds of forces: push, pull and twist. They're all measured in newtons. And this is Sir Isaac Newton. Isaac Newton came up with 3 laws of motion, all including forces of one form or another. Now you need to know what the name of these forces are. Now here we have a car. It's a bit of a slow car, so let's make it a bit faster. Yes, that's much better. So what are the forces? Now there's always a force downwards towards the earth, and that's called the weight, and that's due to gravity. That force is always there when you're near to a large object like a planet, like the planet Earth, for example. Now, the car doesn't sink into the ground. It's held up by the earth. So there's another force pushing opposite the weight, which is called the normal reaction. That will always be there. There's a force pushing forward. This is called the thrust. This is the driving force of the engine. And there will be a force stopping it from moving, which is basically air resistance and friction. So these are the 4 forces that we need to be familiar with. Now let's compare these forces. Now you see all these forces here. The normal reaction and the weight are more or less the same size. The air resistance is going backwards, but the thrust is much bigger. If the thrust is bigger than the other forces, then it will accelerate forward. Since the thrust is greater than the friction, it must accelerate forward. On the other hand, if you're driving forward and you put your foot on the brake, the friction will be greatly increased like this. So the car is moving forward, but the force backwards is greater than the force forward, so it's going to slow down. So since the thrust is less than the friction now, it will decelerate or slow down. Now here we have the same car, same go faster stripe, the weight, the reaction, the thrust, and the air resistance. Now if these forces are balanced, as they appear to be, we have a constant velocity. It's neither going to get faster nor slower. Now what would happen if it were still? It would be the same situation. The forces will be balanced. But in this case, that there will be no thrust and no air resistance. But still the forces are balanced. So in this case it has 0 velocity. So really you can't tell if the forces are balanced whether it's going to be going at a constant velocity or 0 velocity. There's no way of knowing, unless you know that one of the forces is connected with movement, such as thrust or air resistance. Now, what is mass? Now, the mass is the amount of stuff that's inside something, and it's measured in kilograms. Now, from a physics point of view, we look at mass as being something that makes something harder to move. And to give an example, we have 2 sets of masses here. Figure A has a mass of 34 kilograms. Figure B has 12 kilograms. Now, which one is harder to move? If you apply a force to the first one, it's a really large mass, so it's not easy to get it to move. So we get a small acceleration. On the right-hand side, however, you apply the same force, it's going to be much easier to make it accelerate. And that's how we know how much stuff is in something, how much mass something is how easy it is to get it to move. However, for convenience, we don't need to push things to see how much mass is in them. We measure them with a set of scales or a balance, because rather conveniently, if a mass is in a gravitational field, the gravitational field will exert a force on the balance. So the balance basically converts the force that is pushing down on the mass, and it tells you how much mass is responsible for it. So it makes it very easy. We just have to weigh things. We look on the scale, and that number tells us how much gravity is pulling it down. In other words, it will tell us how much the mass is. The interesting thing is the mass of an object does not depend on where you are. We have a mass on the surface of the Earth, and the mass is 1 kilogram. That same mass is also 1 kilogram on the Moon, and is still 1 kilogram in deep space. It still has the same amount of stuff inside it. Weight, however, can be a little bit confusing. What is weight? Now, the weight is the gravitational force that pulls down on an object, and it's measured in newtons, not kilograms. For example, this 1 kilogram on the Earth has a force pulling down which is equal to 10 newtons, or sometimes we say 1 kilogram weight. That same kilogram on the Moon has a much smaller force pulling down, so therefore it will have a smaller weight. It will be about 1.6 newtons. A 1 kilogram mass in deep space, how much gravity will be pulling on that? Well, there is no gravity, so it weighs nothing. This is an interesting graphic. We look at the mass of a spaceman. He weighs 120 kilograms. The weight is basically going to be 120 times by 10 because each kilogram weighs 10 newtons, so it's 1200 newtons. On the Moon, however, the gravity is much less. So while his mass is the same, his weight will be less. It will only be 200 newtons. And that means it's easier for him to jump up in the air because the weight is much less. He only weighs 200 newtons, which is the equivalent of 20 kilos weight. Now, mass and weight, let's look at them together. The mass is the amount of stuff that's in something and is measured in kilograms. The weight is the gravitational force that pulls on an object, and that's measured in newtons. On Earth, conveniently, each mass of 1 kilogram is pulled down on the Earth with a force of 10 newtons. So each kilogram weighs 10 newtons. And that makes the maths very easy. For example, 20 kilograms mass on the Earth has 200 newtons weight pulling down on it on the Earth. So how much will an 85 kilogram physics teacher weigh? All you need to do is basically just multiply by 10. So it's going to be m times g is 85 times 10 is 850 newtons. And there you have it. Easy peasy, lemon squeezy.